Hello everyone. In this video we're going to have a look at the uniform and the adaptive remesher. We will talk about what they are, what they do, and how to use them, and we'll have a look at the differences between the two, and we'll also talk a little bit about when you would use the uniform remesher versus when you would use the adaptive remesher. To begin, we'll have a look at the uniform remesher. We're going to be working with this simple shoe model. As we can see, it's been meshed by Rhino, so we've got a fairly large collection of high aspect ratio triangles here. So these are triangles where one edge is very, very long, but another edge on the triangle is very short. So those are high aspect ratio triangles. We also have some larger triangles down here on the planar surfaces. And we also have some fairly small triangles, especially when we come to the cut lines. So some of these triangles can get fairly small. So what the remeshers do, both the uniform and the adaptive remesher, they are going to scan the topology of the mesh, and they will create a new mesh over top of the original that preserves the detail and the fidelity of the mesh, but the key characteristics of both are that all the triangles are going to be more or less equilateral, and we're going to have a reduced vertex and triangle count. So to begin, we'll switch to the Mesh Tools tab, and we're going to use first the Uniform Remesher. So we'll start the tool, we're going to rectangle select all the meshes, press enter on the keyboard to accept the selections. We're going to adjust a couple of the controls. We're going to first sew all the meshes together. We're going to respect the seam boundaries during remeshing, and when we're done, we're going to unsew. So sewing is going to basically join all the meshes together. Respecting the seams is going to respect the existing divisions between the meshes, and unsew is basically going to explode the mesh back into the same number of pieces that we started with. We're also going to delete the input so we don't have two meshes over top. So before I start adjusting the fidelity percents and the output parameters, we're going to go ahead and click Start, and we're going to have a look at the results. So very quickly, we're creating a new mesh over top of the original. The shape is still very much recognized as a shoe, but we've essentially reduced the triangle count, and this is very noticeable when we start looking at the toe. We've gone from a smooth toe to a very angular toe. So the largest contributing factor to this would be the desired vertex count. For the uniform remesher, the biggest control is the desired vertex count, and this is how many vertices are going to be shared amongst all meshes selected. So for this one, I'm going to change it from 300 to 1200. We're going to click Start again, and we're going to see a new mesh appear. So very quickly, we're going to start remeshing, and already we can see that we've got much more detail around the toe. It's much rounder, and the shoe's looking a lot better. So 1200 vertices for something like this results in a fairly decent looking mesh, and for this I think this would be a good result. We can also control the results of the remesher by adjusting the fidelity percents. So probably the most important ones would be the boundary percentages. So this is going to be the amount of difference allowed between the original boundary of the original mesh and the boundary of the remeshed mesh. So it's important that you don't change these really any higher than 90–95%. If you set them too high, you're over constraining the remesher. It's not going to be able to make the changes required to adequately decimate your mesh. So generally speaking, 90% is about the maximum you want to set these. Lowering these even more is going to allow the remesher to forgive or overlook additional detail, so you might want to lower those values if you're working with a very noisy mesh, perhaps something from a laser scanner that has a lot of noise in it, and that's going to allow the remesh to smooth out that noise. But generally speaking, the desired vertex count is the parameter that you're going to be changing. This is going to make the most difference in the quality of your mesh. We'll have a look now at the adaptive remesher. So we'll click the adaptive remesher in the toolbar, and we're going to rectangle select all the meshes and press enter on the keyboard to accept the selection. So right away, our controls are different, and the most notable change is we no longer have a desired vertex count. The adaptive remesher works differently. It works entirely based off of the desired surface and boundary tolerance and minimum edge length. So these parameters are the maximum allowed deviation between the original boundary and the new boundary, and the maximum allowed deviation between any triangle surface and of the original mesh compared to the triangle surface of the new mesh. So whenever the adaptive remesher will automatically scale the number of vertices required to produce a new mesh that meets these constraints. So before we start adjusting these, I'm going to click the start button and we'll have a look at the results. So very quickly it's going to analyze the mesh and it's going to start creating a new mesh. So we can already see that we've got a mesh very similar to the uniform remesher, but a couple key differences are the triangle sizes are going to scale. So we're going to end up with different triangle sizes with the adaptive remesher, and the reason being is it's going to scale the number of triangles to meet the number of triangles required to preserve detail in the mesh. So around the toe we're going to have more triangles here than we will along a planar surface around the back here. Same with up here around the heel area. We have more triangles up here to preserve detail that was found in the original mesh, and it's going to scale the triangle size to preserve that detail. So for both uniform and adaptive remesher, we're ending up with a reduced triangle and vertex count, which is very desirable for ExactFlat, and we're also ending up with triangles that are more or less equilateral. But the two biggest differences between the uniform remesher and the adaptive remesher are the parameters used to control them. With the uniform remesher, we specify a target vertex count, but with the adaptive remesher, we specify maximum allowed distances between the old mesh surface or boundary and the new mesh surface or boundary. So we can adjust the number of triangles produced with the adaptive remesher by adjusting the tolerance parameters. Similar to the uniform remesher, the most important one to adjust is the boundary tolerance. This is going to change the fidelity of your cut edge. So we can add more triangles by reducing the boundary tolerance. So for instance, I will change this from 3 to 1. And it's always best to match the minimum edge length to the smallest tolerance, so we're going to also change the minimum edge length to 1. Minimum edge length is more of a suggestion, but it is generally the smallest length of a triangle edge that will be allowed to be produced by the adaptive remesher. So we've changed our tolerances. We're going to go ahead and click Start, and we're going to notice that we're going to have more additional vertices. In this case, one of them is estimated to have a vertex count greater than 1,000, so we are getting a warning message. We're going to go ahead and click Yes, and we're going to proceed with the remesh. So we've got additional vertices, and in the case of this mesh here, I'll go ahead and click OK. We can see that we've got areas of local zoning, and this is because the adaptive remesher is preserving some details that were found in the mesh. So if we zoom in real close on one of these areas, I'm just going to rectangle zoom here, and we're going to go ahead and undo the adaptive remesher. We'll notice that we've got a triangle here that has produced a bit of a ridge. So we can see as we rotate this around, we've got a bit of a ridge or a small detail here that's being preserved by the adaptive remesher. So the easiest way to correct this would be to simply delete the triangle and vertex shift this point, or we can split up this triangle. There's a number of ways that we can fix this error, but they're very easy to spot with the adaptive remesher, whereas these errors, they're either obliterated or not possible to spot with the uniform remesher. So in most cases, the adaptive remesher is the tool you are going to want to use. It is the easiest to use, and it tends to produce the best results. It's also much quicker to adaptively remesh a mesh than it is to use the uniform remesher. When working with smaller meshes, the uniform remesher tends to artificially inflate the vertex count before decimating and reducing it, just to give it the highest point sample count required to perform its work. So for those reasons, we recommend you always use the adaptive remesher as your go-to tool for remeshing. Some cases where you may want to use the uniform remesher would be when you're working with extremely large data sets that are very noisy. So if you're working with laser scanned data, the data tends to be noisy and pick up micro variations in the surface. These would all be good candidates for the uniform remesher. They can be used, the uniform remesher can be used to smooth out micro variations in the result. So when we compare the adaptively remeshed result here, the adaptive remesher is preserving all these imperfections in the original mesh, whereas the result we got from the uniform remesher, it did not have these small details, so it tends to smooth out imperfections in the result, and this is desirable for laser scanned models. Uniform remesher is a good choice for data that's coming from very noisy sources such as laser scan data. Otherwise, it's always recommended to use the adaptive remesher. Thank you for watching.